Good morning, hope everyone's well. Today we're going to be looking at degeneracy in non-homogeneous second order differential equations. So, if trial function you choose for your particular integral is the same as part of the complementary function you must add in an extra x to your particular integral. Okay, and I'll demonstrate as usual by example. So example number 1. So this time we'll just be finding the general solution. We'll do a particular solution in example 2. Okay, and our differential equation is d squared y by dx squared is equal to 5 dy by dx plus 6y equals 8e the power of 2x. So it's a general solution, so I don't need to have initial conditions. So as usual, we set up the auxiliary equation. It's actually going to be m squared to equal to 5m plus 6 is equal to 0. And again, c dt, so common factor, difference of two squares, trinomial, but we can clearly see there's 3 bits, so it's a trinomial, so it's an add and a multiply like normal. So again, I'm going to be adding to make negative 5 and multiplying to make plus 6. So all of the ways making 6, 1 times 6, 2 times 3. Well, which ones add together is 5? Well, 2 and 3, but it's negative 5 I want, so it's negative 2 and negative 3. And just check that. Negative 2 multiplied by negative 3 is positive 6. Negative 2 add negative 3 is negative 5. So that's m to equal to 2. M to equal to 3 is equal to 0. So m to equal to 2 equals 0. And m to equal to 3 equals 0. So m is 2 and m is 3. So again, just like yesterday, you go through or you look at your 3 different cases and you decide that these are both real numbers and they're different. 2 and 3 are different numbers. So we know that's case number 1. So that means that a complementary function is y equals ae to the power of 2x plus be to the power of 3x. Right, now what we need to do is work out our particular integral. So we need to come up with our trial function. So we'll look at our table, and as I said, the table will be given to you in the exam. So there's our trial function table here, and we see that the solution, or the right hand side of our differential equation, is 8e to the power of 2x, which means I need to use a particular integral for an exponential. So down here is my exponentials, and that's just telling me, well, I keep the number that's next to the x, but I don't have a number in front. I change that to a c. So that's what I'm going to do. So our trial function would normally be y equals ce to the power of 2x. But that's very similar to that. In fact, it's exactly the same function, apart from it's got a different constant at the front. So I can't use that as my trial function. Okay, can't use that as a trial function because it's already been used as part of my complementary function. And that's what I said here. If the trial function you choose for a particular integral is the same as part of the complementary function, that means we must add in an extra x to the particular integral. So the trial function we're actually going to use is y equals cx e to the power of 2x. Now, I will at the end explain to you why we can't use that, but just now I'll just continue with solving this second order differential equation. So we know now we differentiate this part twice and we substitute it back into our original differential equation. So the issue we have here is that this is a product. So when I differentiate it, I'm going to have to use the product rule. So that means that dy by dx, differentiate the first one, I get c, leave the second one alone, e to the power of 2x, plus, leave the first one alone, multiply by what I get if I differentiate the second one, is 2e to the power of 2x. So that means that dy by dx is ce to the power of 2x plus 2cx e to the power of 2x. Okay, now I've got to differentiate it again, so I'll just note that's my y, so that's what I'm going to be substituting in my y, that's what I'm going to be substituting in for my dy by dx. So now I'm going to have to differentiate this again. This bit is easy enough, it's just a normal function, but this again is a product rule. So I'm going to take that to be my 1, take that to be my 2. And I'm going to put my product rule here in a bracket. So here, differentiate that, which gives me 2ce to the power of 2x. Differentiate this here, so that differentiate 1 gives me 2c, leave 2 alone, e to the power of 2x, plus leave 1 alone, multiply by what I get if I differentiate the second one, and that again gives me 2e to the power of 2x. So again, differentiate like normal, and here I've used the product rule. I've got my two terms. Just simplify that down as much as I possibly can. And hopefully you can see that these are like terms, so we can add them together to just simplify it. Right, so I've worked out my two derivatives. So I've worked out y, chosen y. I've had to put an extra x in it because it looked like part of the complementary function. I've differentiated it once using the product rule to get this here. I've differentiated it again, this time using the product rule in this bit here, and simplified it as much as possible. So I've now got three things d squared y by dx squared, dy by dx, and y that I can substitute into my original differential equation. So my original differential equation was d squared y by dx squared take away 5 dy by dx plus 6y equals 8e to the power of 2x. So I substitute in those values, so that's 4ce to the power of 2x plus 4cx e to the power of 2x. Take away 5, multiplied by ce to the power of 2x plus 2cx e to the power of 2x, plus 6 cx e to the power of 2x. And remember, that is equal to 8e to the power of 2x. So I'm just going to multiply the brackets and simplify as much as possible and equate coefficients or do whatever it is I need to do. So 4c to the power of 2x plus 4cx e to the power of 2x, take away 5c e to the power of 2x, take away 10cx e to the power of 2x, plus 6cx e to the power of 2x equals 8e to the power of 2x. Okay, and you want to collect like terms. So hopefully you can see here that these are like terms, that's like term, and that's like term. So 4 plus 6 is 10, take away 10 is 0. So those, that one, and that one cancel each other out, just simply because they're like terms and through adding. Here, 4c take away 5c is negative c, so I've got negative c e to the power of 2x equals 8e to the power of 2x. So that means that negative c equals 8, so c is just equal to negative 8. So that means that my particular integral, which my trial function with cx e to the power of 2x is just negative 8x e to the power of 2x. Right, so remember to get your general solution, which is what I'm looking for here. It's just y equals your complementary function plus your particular integral. So my complementary function is ae to the power of 2x plus be to the power of 3x, and my particular integral is negative 8x e to the power of 2x. And that is my final solution. That would be worth between 10 and 12 marks for a question like that. Now, what I want to do is go back and show you why choosing the trial function y equals c e to the power of 2x wouldn't work. So let's go back to the first page. So this was our differential equation, done our auxiliary, worked out our complementary function, and I had said that y equals ce to the power of 2x won't work because it's already part of the complementary function. Right, let's see why. I'm going to do it as if this is going to work. I'll show you why it doesn't. So don't copy. So if I choose my complementary function, as I said won't work, is ce to the power of 2x. Then we differentiate it once. 2ce to the power of 2x, differentiate it twice. 4ce to the power of 2x. Right, and we substitute that into the original differential equation. So all I've done is what you would expect to do. So I'll substitute those values in. So we've got 4ce to the power of 2x, take away 10 ce to the power of 2x plus 6 ce to the power of 2x equals 8e to the power of 2x. Now, what you should be able to see is 4 take away 10 is negative 6 plus 6 is 0. So this side should be 0. So 0 equals 8e to the power of 2x. So there's no way of calculating c. So if you get 0 when you're trying to find the c value for your particular integral or a c value for your trial function, it means that you've chosen the wrong trial function.